Hi everyone, welcome back to Geeks for Geeks. In this video, we will discuss the problem populate in order successor for all the nodes. So let us see what the problem says and how we can solve it. Basically, this problem is based on binary trees. If you will see this problem, it says that you will be given a binary tree and we have to write a function in order to populate the next pointer of all the nodes to the in order successor. Now what is the in order successor? Let us say that we have been given a tree. Let's say we have been given 1, okay, then we have been given 2, then we have been given 3. So if a tree is given to us, now what is the in order traversal for this particular tree? Now the in order traversal will be, basically in order traversal is what? First of all we write the left, then we write left subtree, then we write the root, okay, and then after that we write the right subtree, correct? So in this case, first of all, we'll be at 1. From 1, we'll go to the left. So we'll go to 2. For 2, its left is null. So now we'll write 2 here. Okay. Then we have to go back up. Then the next element that will be written is 1. Now with respect to 1, we'll call on the right subtree. So we'll call for 3. With respect to 3, there is nothing on the left. So now we'll write 3 here. And then with respect to 3, there is nothing on the right. So we'll go back. Now you can see this is the in order traversal. And for this in order traversal, for every node, whichever is the next node for it in the in order traversal, that has to be updated. With respect to 2, the next in order successor is 1. The next in order successor is what? It is 3. So this is how it will be updated, and with respect to 3 there is nothing, so you can say it will be updated with null, or you can also say -1. So this is what they are expecting for the second test case. If you'll observe, so you will have 2, then you'll have 1. From 2 there is an arrow going to 1, and then from 1 there is an arrow going to 3, and then from 3 there is an arrow going to -1, which means that the node does not exist. The right successor for 3 does not exist here. Okay. Now if you will see the second test case, let's say we have got what? Let's say we have got 10 here. Okay. Then after that we have got what? We have got 8 here. Okay. Then we have got what? We have got 12. And then we have got 3 here. So if this is the tree that we have got initially, right, so you can observe one thing, that whenever we come back from the right for a particular node, whenever you are coming back from the right node, then you will have the access to the right successor, to the in order successor. So basically, when first of all you will call on the right, and when you come back from the right, so you will keep a variable and you will store the right in order successor. And whenever you are at a current root, so first of all you have called for the right subtree. When you have called for the right subtree, so a variable will be able to store the in order successor, and then for the after coming back from the right call of the current root that you are at, you will update the current roots next to the in order successor that you have stored. So let's see this how you can do it, because basically what will happen here is, first of all your next right, let's say you can have a variable you can have a pointer which can store the node. So basically initially the next in order successor on the right side will be null, so I'll mark it as null. Okay, initially I'll mark the variable as null. Now when I start from 10, so whenever I start from a particular node, since I want the in order successor, so this means that I will travel first of all on the right side whenever my right call is over. So the next right pointer will be storing the in order successor for me, because whatever is the right element, that will be stored in the next right pointer. So let's see the dry run here. What will happen here is, first of all initially you will be having what? You will be having 10. Okay, when you are at 10, so as I said, you will first of all make the priority to call on the right side, on the right subtree. So you will call for 12. When you are at 12, then you will call for the right, so you are at null. Okay, so after this you will come back to 12. So for 12, with respect to 12, you are coming from the right subtree. When you come back from the right subtree, then for the current root, what you will do is you will update the data with the, like you will update the current root nodes next to the next right. So basically you will say that current root that you are at, its next would be equal to what? Its next will be equal to whatever is stored in the next right. So basically 12's next will be updated to null. Okay, and then when we are then after this, what we'll do is, when we are going away from this node, so we need to update the next right pointer to this node 12. So now next right will be 12. Now with respect to 12, I have already called on the on the right side. I've already processed 12 as well. Now I'll process the left part. So when I go on the left, it is null. So since it is null, then we can directly move back. So when we move, So with respect to 12, the right is processed, 12 is also processed, and its left is also processed. So we'll go back. When we go back, so still the next write is 12. Now after this, currently we are at the node 10. So when I'm at 10, so with respect to 10, what will happen is, with respect to 10, I will update its next to the next write pointer. So basically next will 10's next will be updated to what? Current node is 10, so its next will be updated to 12 here. Right, so its in order successor will be updated, and then I'll update the next write node to 10, because now the successor will be 10 for other nodes. Now with respect to 10, what I'll do is I'll call on the left side. So I'll call for 8. Now when I call for 8, so first of all, with respect to 8, I'll try to call on the right side, but the right side is null. So since the right side is null, I'll go back. Now I'll be at the node 8. Okay, because first of all, whenever I'm at a current node, I have to go to the right subtree. Then when I come back, so I have to update the in order successor for the current node, and then I have to go on the left. So with respect to 8, I'll update the in order successor or the next node as what? As the next write. So with respect to 8, 10 will get updated. Okay, and then I'll update the next write in order successor as 8. Okay, then with respect to 8, now I have to call on the left, so I'll call for 3. When I'm at 3, I'll call for right child is null, so I'll come back to 3. When I'm at 3, so with respect to 3, I'll update the next as the in order successor, that is the next write. So basically 3's next will be updated to 8, because for 3 the in order successor is 8. Okay, so it will be updated, and then after that the next write will be stored as 3, and with respect to 3, you will call on the left also, but it is null, so you will go back, then you will go back. Now you can see with respect to 10, the right calls are also done. 10 has also been processed, and its left subtree is also processed. So you can see that the diagram that we are having, it is basically storing the nodes of the tree in the format such that every node is pointing to its in order successor here. So I hope that you have understood the dry run of this particular approach so far. Now let's try and write the code for this. So what I'll do here is, first of all, let's update a variable here. So first of all, I'll update a node variable. Let's say node star next write. Okay, that will be basically null initially, because initially I'm just going to start off. Now as I said, if I'm at a particular current root which is null, so if I'm at a particular current root which is null, then I can simply return away from there. Otherwise, what is the next thing that I'll do? Otherwise, I'll call my function. Otherwise, I'll call my recursive populate next function. First of all, on the right subtree, if the current root is not null, so my priority will be that I need to call on the right subtree. Okay, when I call on the right subtree and when I come back, so for the current root I have to update. So what I'll do is I'll say that for the current root, its next in order successor will be updated as what? Will be updated as whatever node is stored in the next write. And then after that, what will happen? Before leaving this particular current root node, my next write will be pointing to this particular current root, as I said. And once I have processed my right subtree, I have processed my current root, that is for the current root, I have updated its next in order successor. Then what I need to do is, I need to update my next write root as the current root, and then I need to call the function on the left subtree. So I'll call the root left here. So this is what we can do, and this is how my in order successor for every node will get updated. Now let's try and compile this to see if it is working fine or not. So you can see it is working correctly on the samples. Let's try and submit this particular code to see if it is getting accepted or not. And yes, you can see that the code gets accepted in the very first go. Now talking about the time and the space complexity of my code. So basically the time complexity for my code will be nothing but order of n, because we are iterating through every node exactly once. Talking about the space complexity, since I'm using DFS based recursive approach, so it will be order of n in the worst case, because recursive stack space will be taken because of using recursive function, and in the worst case the tree can be skewed, that is tree can be only in one direction like this, or all the nodes can be like this. So that is why overall it will be order of n space complexity because of recursive stack space that can occur in the worst case. I hope that you have understood this problem clearly. In case you did, make sure to comment down understood, and make sure to hit the like button as well. If you have any confusions or doubt, you can mention them in the comments and I'll try to answer them as soon as possible. Thank you for watching this video, guys.